Hi, everyone. I'm Rabab Al-Omari, postdoctoral fellow at Julia Lab at MIT. So, as we may know, solving accurate atomistic simulation of material properties require solving complex quantum mechanical equation, often taking several weeks or months, even if we use approximate method like DFT. So, to speed up this calculation, machine learning model come and unlock these challenges, and which prove to be which provide fast approximation and promising accuracy across diverse atomistic simulation. However, further acceleration and accuracy is needed, even especially when solving complex and large material atomistic system. So here I propose using different dimensionality reduction technique to tackle this challenge for nonlinear problem and linear problem, and which show promising accuracy and speed up. So here I use different functionality from Julia programming languages, which provide seamless integration and robust accuracy for our computational model. So if you want to learn more, come and visit my poster, which is the first one when we're starting the poster session. Thank you so much.
Hello. Hi, everyone. I'm Devankita Basu. I'm a graduate student at Northeastern University, and I'm here to present my work on unveiling digital truths in defect detection. So defects are manipulated images, videos, any kind of media using very sophisticated AI. With the advancement in technology, it is very essential and crucial for us to find tools which will help us to detect and differentiate between the real and the fake images, especially in social media, where information is misused and we see a lot of fraud and scams going on. So in my project, I am using leveraging two deep learning models. One is the state-of-the-art convolution neural network model, and the other one is the visual transformer model. And I see CNN performing a lot better than the visual transformer model. And in my project, I'm aiming to find which one of the models surpasses the other in terms of this detection journey. So to learn more about my work and my findings, please join me at the poster session, and I'll be happy to answer any questions. Thank you.
Hi, my name is Julia Bryden, and I'll be presenting on the poster session on constraint-informed learning for worm starting trajectory optimization. And so for future spacecraft and robotic missions, more and more complex control schemes are required to be able to operate in uncertain and randomized environments. And so, for example, we are looking to use model predictive control on board our radiation-hardened processors. A current issue is that MPC is too computationally expensive to use on board. And a potential solution that we looked at in this work is learning a problem solution mapping to warm start that online optimization problem. And so looking into kind of out-of-the-box learning-based methods for predicting this mapping, we found that if we use mean squared error, then we might have, for example, a very low mean squared error, but still endure a significant amount of constraint violation. So how can we encode constraint satisfaction while we're learning? And so what we did in this case is use an optimal control problem kind of formulation through the Lagrangian. And so if we use the Lagrangian as a merit function where we balance both the cost minimization and constraint satisfaction, then we can use that to provide a sense of inherent constraint satisfaction or bias towards constraint satisfaction while we're learning. If you'd like to learn more, come visit me at the poster session. Thank you.
Hi, I'm Sarah Caudill. I'm going to be talking to you about data analysis with LIGO, which is the Laser Interferometer Gravitational Wave Observatory. So we have these two detectors in the US that are basically measuring ripples in space-time, and they have to be exquisitely sensitive in order to do that. And as such, our data is often contaminated with glitches and all sorts of environmental noise sources that give us false alarms in our data. And so you can see here an example of an actual black hole signal versus a kind of detector artifact that contaminates our searches. But if we're able to overcome those artifacts, we can find signals from binary black holes and binary neutron stars and things that do not emit light and cannot really be detected in any other way. So it's a very interesting physics problem. And so if you want to stop by my poster, I'll tell you how we're using deep learning for our detection in order to distinguish between signals and background, and also anomaly detection to find new sources that we haven't discovered yet. Also, how we're using generative adversarial networks for simulated data generation and other complex problems related to the high-dimensional space that we have to sample for these parameter spaces. So, thank you.
Hello, I'm Elisabetta Cornacchia, and I'm going to talk about provable advantage of curriculum learning on parity targets with mixed inputs. So curriculum learning refers to the strategy of presenting samples to a learning algorithm in a meaningful order. So for instance, starting from easy samples and then moving to complex samples only on a later part of training. In this paper, we want to find a theoretical explanation of curriculum learning. So we focus on a very stylized settings, which is learning parities on Boolean mixed inputs, so inputs that are a mixture of easy samples and hard samples. And we compare two strategies. The standard training would be samples are selected at random at each training step from the whole data set. And in curriculum training, we focus only on the easy samples for an initial part, and then we move to all the samples subsequently. And with what we show is that at least in some regimes, curriculum is beneficial in the sense that it reduces the number of training steps that are needed to learn. And yeah, you can learn more at my poster session.
Hi, I'm Yi Fuding. I'm from the MIT Energy Initiative. I'm currently a postdoc working on the power system planning for Indians. As you may see this in this poster or slides, that we're trying to understand Indian net zero power system planning through data-driven coal power plant retrofitting options. So India has the largest population in the world, and its energy demand is going to double by 2013. And currently, the most of the power generation in India is still coal power plants. So this research will using the machine learning to analysis and understand the coal power plant in the Indians and trying to find which is the best way to retrofit those coal power plants. We found that using the smart data-driven coal power plant retrofit option can save the significant system costs. And please come to my poster and find out the results. Thank you.
Good morning, I'm Nancy, and together with me here today are my teammates Danny and Haning, and we are excited to share our work on understanding defenses against adversarial attacks on large vision language models. Large VLMs are made it possible to solve complex tasks in the multimodal tasks. However, these models are also very susceptible to adversarial attacks, raising profound concerns on safety and reliability. So in this work, we advance our understanding of VLM robustness, and we also interpret the defenses and adversarial attacks on VLMs through image embeddings. We generated 62 adversaries, and we also applied 6 defense mechanisms on all of these images. We also visualized the embeddings of the images for clean adversarial and defense images. Join us today to enhance VLM robustness, and thank you very much, and we look forward to seeing you during the poster session.
Hi everyone, I am Shrestha Mohanty, a graduate student at MIT, where my research focuses at the intersection of natural language processing and computational social science. Here, I'll be presenting my work on benchmarking clarifying questions in interactive grounded language understanding agents. The motivation behind our work was to elevate user and agent communication by integrating feedback mechanisms so that they can communicate effectively, and also eventually they can help us solve real-world tasks. Our contributions include a data collection tool that is scalable and it is open sourced, and we're able to collect multimodal data with that. Along with it, we have also released 2 data sets that is anchored in building tasks on gaming environment like Minecraft. And the data set consists of human annotated action instruction pairs and a set of clarifying questions. We have also released a set of baselines for the clarifying questions task. So when an instruction for the building task is unclear, then the agent can seek more clarification. To learn more, please stop by my poster. Thank you.
Hi everyone. My name is Swati, and I'm a postdoc at MIT. This was work I did as an intern at Google DeepMind during my PhD. So the goal of this is a paper on computing approximate LP sensitivities, where the main task is you're given a sum of functions that you want to optimize, and you want to figure out how to sample them in an effective manner so that the size of your data set that you eventually have to work with shrinks enough while still being approximately as close as possible to the original data set. So this is motivated by a lot of machine learning tasks. For example, if you want to compute, if you want to do least squares regression, the function in question would be the sum of L2 norm squares. So in this paper, we give a number of theoretical algorithms for computing LP sensitivities fast. And this was published in NeurIPS last year. For more details, please come to my poster session later. Thank you.
So, hi, my name is Agatha. I'm a last year PhD student at UMass, and I'm a physical oceanographer. And that means I study physical processes that move the ocean. And in my PhD, I look into the fluid dynamics that mix the river water into the ocean that you can see here from the very distinct differences in the color. And this is very important for coastal management. And it requires a lot of intense data analysis, and we use a lot of instruments to capture our data. And we'll be talking a little bit about how I analyze, how I process the data, and how I got the conclusions for my work. Yeah, thank you.
Good morning, everyone. My name is Jessica Quay, and I'm a PhD student at the Harvard Edge Computing Lab. I'm very excited to share with you this morning our work on generative AI, responsible AI for generative models. So since the rise of text-to-image generative models like DALL-E, Stable Diffusion, Midjourney, for the most part, I'm sure you've seen a news report on these models generating inappropriate images. And most of the time, the techniques that are used to generate these inappropriate images are explicitly adversarial. So it's either some prompts, some words or some phrases were injected into the prompt, or there was some obfuscation of some text somewhere, or sometimes even the models themselves are fine-tuned in such a way that the safety parameters are imbalanced. However, we found that there was some space of prompts where even though the text is not adversarial or the text has no intention to trigger a violation, these prompts did end up generating inappropriate images, and that's what we sought to explore that space. So what we did was we organized a prompt engineering crowdsourcing challenge where we've gathered interesting examples of these kinds of prompts. And in terms of next steps, we are looking how do we then map this space and ensure that in the future, future models don't have these kind of problems. If you're interested in learning more about the kinds of examples we had, stats on the data that we collected, so an analysis on how humans perceive safety versus how certain models and their classifiers perceive safety, as well as the future work plans we have, please stop by my poster session later today. Thank you.
Hi, everyone. My name is Shreya. I'm a first-year PhD student at MIT. Today, I'm going to be talking about stop-and-go traffic, which is something commonly experienced on highways. Probably all of you have been in stop-and-go before. It's kind of this oscillating pattern of accelerating and then decelerating. And we know they're bad. They result in increased emissions, increased safety hazards, as well as wasted time for drivers. We can actually visualize them in a snapshot of time and space as these jagged red slow speed stripes that are circled in blue. But the good news is that this type of traffic phenomenon can be avoided with targeted interventions. There's been a lot of work in using autonomous vehicles and other forms of smart infrastructure to smooth out traffic waves. So why haven't these technologies been deployed? The main concern is that the data to identify when and where these events occur is way too sparse. So what this work is on is using the sparse highway data to then reconstruct a full picture of what happens in traffic. And then we're able to extract our features of interest and do some analysis on that. And the end goal of this is to be able to, one, more effectively deploy interventions so that we can, target stop-and-go traffic and mitigate it. But also, we want to quantify the opportunity that mitigating stop-and-go presents. So if this interests you, feel free to stop by my poster later today. Thank you.
Hello, everyone. My name is Sol Rosito. I am a mathematician with a PhD in physics, and this work is based on research conducted at the University of Buenos Aires and the Catholic University of Chile. Given the vast and increasing access to astronomical datasets, to huge astronomical datasets, the need for machine learning to study and classify galaxies is growing. Unsupervised approaches are crucial for defining novel galaxy groups that often outperform existing classifications. So here I present Scan Galactic. That is a method that combines a dimensionality reduction algorithm, UMAP, followed by a clustering algorithm, HDBSCAM. The input of the method consists of images in which each pixel represents a kinematic quantity. In our work, we compute those images using galaxies from the Eagle cosmological simulations and through statistical analysis based on observational and physical properties of galaxies. We could demonstrate the meaningfulness of each classification for different inputs, different experiments. And here I show an example of the application of the method to one of those experiments. We have the clusters, their sizes, heat maps of different properties in the projection, and the distribution of the properties in different clusters. So you're welcome to visit my poster. Thank you.
Hi, I'm Erin. I'm a PhD candidate in social and engineering systems at MIT, and I'm presenting on some work I've been working on about segregation in online content viewership, specifically looking at whether Republicans and Democrats are viewing different content online, if this extends beyond news content, because there's this sense that polarization has been increasing to a lot of different areas and not explicitly the areas that we think of as being kind of some Democrat, some Republican opinions on them. And then also thinking about how the level of aggregation impacts results. So something like if we're looking at URL level analysis versus domain level analysis, is this going to change the amount of segregation we see in what people are viewing? Would love to see all of you at the poster session. If you have any thoughts, questions about this, or have access to data sets about people's partisanship, would love to talk to you.
Hi, everyone. My name is Jachi. I'm currently a fourth-year PhD student at MIT, advised by Caroline Wooler. I'm here to present our work on membership testing in Markov equivalence classes. So learning and testing are actually very well-studied problems in many fields, with testing becoming particularly relevant in scenarios with limited data. However, much of causal discovery has mostly focused on learning. This is the problem where you are given a data matrix on tabular data, and you're trying to infer the underlying causal structure. So for this problem, most constraint-based methods typically use a number of conditional independent stats that's exponential in degree of the graph. So with observational data, the underlying causal graph is generally only identifiable up to their equivalence classes. For this, we asked the natural testing question. which is given a specific MEC, Markov equivalent class, can we determine if the underlying causal graph belongs to it with observational data. So for this, we show matching lower and upper bounds in terms of the number of conditional independence tests that are needed. So this is a number that's better than the current number used by most algorithms for learning. And we also provide a geometric interpretation of testing versus learning on the DAG-associated hedron. So if you're interested, please visit us at the poster session. Thank you so much.
Good morning, everyone. I'm Xiaohan. My teammate and I are data science master from Harvard, and we are excited to share with you our work on quantifying the differences in human and LLM-generated survey response. Our partner conducted online survey to understand the impact of racism on young people's mental health. However, ChatGPT are misused by people to generate fake response to collect survey payment. So to tackle this challenge, we address both the generation and detection side of fake response. We curated the first benchmark dataset by simulating human subject and developed different detection methods. Our work provides a holistic framework for enhancing the reliability and authenticity of mental health survey data in mental health research. To know more details, check out our poster. Thank you.